Okay, so we just finished talking about end behavior, which is where we were talking about what happens on a graph at the ends of the graph. What is it doing as it approaches negative infinity, and what is it doing as x approaches positive infinity? What we're going to talk about today is what's going on in between the endpoints. So basically everywhere else along the function. We're going to talk about the concept of increasing, decreasing, and constant behavior of a function. So the first thing we need to do is learn what these three words mean and try to make it as simple as possible. So a function is increasing on an interval. That just means from a certain point on the x-axis to another point on the x-axis. So in this picture, this function is increasing from x1 to x2. But a function is increasing if for any 2 points a positive change in x results in a positive change in f of x. Basically what that means is x increases and y increases. And so if you look at the picture of this graph, you'll see that everywhere that the x values are increasing as we move from left to right, the y values on the y-axis are also increasing. Decreasing means that everywhere on the graph as the x increases, the y decreases. So if you look at this picture, the graph to the right, we see that as we move along the x-axis, as we move from x1 to x2, so we increase along the x-axis, the y values decrease. So don't make it more complicated than it has to be. Increasing means x increases, y increases. Decreasing means x increases, y decreases. And the last one, constant, which is what's happening in this picture from x1 to x2. Constant means it's kind of just like a flat line. It's not going up, it's not going down. So constant is x increases, y stays the same. And so you might be thinking to yourself, well, how is x increasing all the time, even if we say it's decreasing or it's constant? Just remember that when we read a graph, we always read it from left to right. So in all these pictures, as we're looking at them, we should be thinking the x is always increasing because that's the way we read a graph. Increasing, decreasing, and constant behavior is always written in terms of the x values, reading from left to right using parentheses only. Okay, so no brackets, and you'll know what I mean by that in a second. So when we look at this graph right here, we're going to say that it's increasing right here because as we go from left to right along the x-axis, the graph is increasing along the y-axis. Then when we get to this point here, from -5 to 0, our graph stays constant. The y values don't increase or decrease. And then when we finally get to this point, we see that our y values begin to decrease. So our graph is decreasing from 0 to infinity. The way that you can mark a graph without drawing on it like I did there is to just use arrows. So this is increasing, this is decreasing, and constant we can just say it's not increasing or decreasing. You could put an arrow if you want, but the idea is that you recognize that increasing is going up, constant is staying the same, decreasing is going down. To describe this, what's going on here, we would say that we are increasing from negative infinity to -5. Remember, it said we read from left to right and we use parentheses only when we're talking about increasing and decreasing. Brackets are when we're talking about domain and range. So then we're constant from -5 to 0, and then we're decreasing from 0 to positive infinity. We're going to practice that a couple of times. All right, so let's take a look at what we have here. We've got a graph, and it says to describe the increasing, decreasing, and constant behavior of the function. So if we look, this graph at this section is increasing. When we get to this point right here, which is labeled for us conveniently, the graph starts to decrease, starts to go down. And we get to this point, which is labeled again for us, the graph starts to go up. So real simply from this picture, we can say that we're increasing from negative infinity, because we start way down at negative infinity. But remember, we're talking about the x's, so it's not really way down here at negative infinity, it's way out here at negative infinity on the x-axis. So from negative infinity to here, -1, and I know that's -1 because it's listed right there, we're increasing. And then we decrease from -1 to +1. And then we start increasing again, going back up, but remember, we're using the x values to describe it. So from +1, which is right here, to infinity, we're increasing again. And that's it. We've described the increasing, decreasing, and constant behavior. There just was no constant behavior in this one. So on B, we can assume that this has arrows on the end, even though the picture doesn't have them. We start way out here on the x-axis at negative infinity. Well, we start immediately increasing, then we have a constant section, and then we have a decreasing section. So we're going to increase from negative infinity to -2, because remember, x-axis, this point right here is -2, and this point, +5. Then we're going to be constant from -2 to 5, and we're going to finally decrease from 5 to infinity. So increasing and decreasing has a lot to do with just being able to look at the picture and describe what's going on. So there's not usually a lot of fancy math that has to go along with it. Okay, so we look at this one, g of x equals x cubed minus 3x. Well, we see increase, decrease, increase. So we get a little more tricky here because the points aren't labeled for us, so we'll go ahead and mark them on the graph. But these points I'm marking, these are where things are happening, right? It's where it's changing directions. And we're going to learn about these in a minute. These are called maximums and minimums. And anytime you have a maximum or a minimum on a graph, that means it's changing directions, because to have a maximum, we had to go as high as we could, and we have to come back down, or that wouldn't be the maximum. So this one is increasing from negative infinity, remember, negative infinity on the x, to right here, -1. It's decreasing from -1, we're on the x, to +1. And then it's going to pick back up again, increasing from 1 to infinity. Okay, so the big idea is that you can just describe where it's going up, where it's going down, where it's going up again, where it's staying flat. That's the idea behind increasing, decreasing, and constant. Now, on the next page, we're going to talk about what I just mentioned, a maximum and a minimum. There's something called an absolute maximum, and there's something called a relative maximum, and also a minimum. So let's look down and look at this first picture. In this picture that we see right here, we have this y equals f of x. I have these 2 points. Now, this point A, this point is, it's the highest point between here and here. So for this distance, or this interval, that is the maximum. But then we look over here and we see this other point that's even higher. So while it's also a maximum, one is kind of the absolute maximum, which is the highest the graph goes. So this one's the absolute maximum. And then the other is a maximum, but it's not the absolute maximum. It's called a relative maximum because it's relatively the highest point on the graph if you're talking about a small interval. Now when we look at this graph down here, it has the same thing. It has minimums. So we have on this little interval here, this point A is the lowest point on this graph. So that makes it a relative minimum. But we have this point, point B, which is the absolute minimum. So remember, maximum and minimum, max just means the highest point on the graph, minimum means the lowest point on the graph. A relative max or minimum is on some interval. Okay, an absolute max or minimum is the greatest value over the entire domain. Or if we look at the minimums, a relative minimum is the least value on some interval, where an absolute minimum is the least minimum over its entire domain. That means all the x values. So hopefully this vocabulary makes a little sense. Relative max is in an area, interval. Absolute max is the whole thing. So steps for calculating max and mins on a graphing calculator. After you graph something, so you put it in y equals, we take this thing right here and we put this in y equals on the calculator. There's going to be certain steps. So after graphing, you're going to push second, calc, and then you're going to either pick option 3 for a minimum or option 4 for a maximum. And then you're going to select a left bound, a right bound, and then you're going to guess. So I don't know if you have a graphing calculator with you right now. What we'll do is save this for class tomorrow. So go ahead and stop here, and this is the first thing we're going to do when y'all come into class tomorrow. So have a great night.